torque, and as they say in some books, it rhymes with fork, although spelled quite differently. Torque, it's a twisting effect created by a force and a lever. You can use a capital T for torque, but the Greek letter tau, T-A-U, is typically used, or used quite frequently. It's kind of like a small t, so tau. Anyways, tau stands for torque. The units are Newton meters. Let me explain. Because torque, in the formula you see here, is R cross F. It's a cross product, which is different than a dot product, which we learned about when we did work problems. But cross products involve the sine of the angle between the two vectors, or the two quantities involved here, the radius or the length of the lever arm and the force applied to the lever arm. And if you remember back, the dot product with work problems was the cosine of the angle. So R is the length of the lever in meters, F is force in newtons, and theta is the angle between the lever and the force. And we want to have a 90-degree angle because the sine of 90 is 1, and 95% of our problems will be with a 90-degree angle, and assume it's 90 degrees unless you're told otherwise. Torque is a vector. The two directions can be clockwise, CW, or counterclockwise, CCW. The center of gravity will be important in most torque problems except for the first two you see here, the entry-level problems. I'll give you a few examples in a few minutes, but when we calculate torque, we will be placing the entire weight of an object at its center of gravity, its CG, as you'll see in the next examples after these two. But here's some entry-level problems. Calculate the torque on a bolt if you apply a 30 Newton force to tighten or loosen the nut or the bolt. So here's our nut. This is my wrench. I'm applying a force right here of 30 newtons. So let's calculate the torque. The torque, tau, will be R cross F. So that'll be R, the distance, and the distance here, the length of this lever is 25 centimeters. 25 centimeters, which is 0.25 meters, times the force applied, 30 newtons, times the sine of 90 degrees in this case, because I'm pushing perpendicular to the wrench, which maximizes your torque. If we do the calculation here, since the sine of 90 is 1, basically 25% of 30 is 7.5 Newton meters. In this case, this would be counterclockwise. It's going to spin counterclockwise, which is usually loosening a nut. Alright, question number 2 here, or example number 2. You have a steering wheel when you're steering your car. And you have, I don't know, some support members in here. The diameter of the steering wheel is 44 centimeters. What's going to be more important here is the radius. How far, for example, if you apply a force, say this way, tangentially to a point on the outer rim where you normally hold onto a steering wheel, the force you're applying here is 5 newtons. The distance from the center of rotation will be 22 centimeters. So the torque is R cross F. The torque equals the distance, 0.22 meters, half of 44 centimeters is 22 centimeters, times the force, 5, times the sine of 90. Now you don't need to keep writing sine of 90 if it is 90, which it is in this case. Your tangential force is perpendicular to the radius. But doing the calculation here, 5 times 0.22 gives you 1.1 or 1.10 Newton meters. And this way, once again, it's counterclockwise, CCW. So you're turning to the left if it's your car.